C program of linear search method that uses recursive and non-recursive functions to search for a key value in a given list of integers. Okay, this is a program of linear search. In this we use recursive function and a non-recursive function. Recursive function means a function is called by itself is called a recursive function. Non-recursive means in this we use loops. For loop, while loop, do while loop. In this iteration will be there, iteration of statements in a loop. But whereas in recursive, a function is called by itself. Okay. So advantage of the function, reusability of the code. Once you write as many as times, we can reuse. Reusability of the code, that is the function. In recursive we use function. In non-recursive we use loops, for loop, while loop, do while loop. Okay. Now we are going to see the linear search method. Okay. This is the searching method. Searching is finding a particular element from the given list. Okay. That is the linear search. What we want the element we can find from the given list. Okay. That finding element is called key element. Okay. Here you see here. Now I am going to start the program. Okay. Here this is the program. Here is the header file. This is the macro definition. Here we can define our own values. Where you use maxlen, at that place 10 will be replaced. This is the macro definition. Okay. Here this is one of the command of preprocessor commands. Okay. Here about the main what I write, they are preprocessor commands. Okay. These are the prototypes. About the main what we write, they are called signature of a function or prototype of a function. These are the prototype of functions. Okay. Now I am going to use these functions in my program. Why we write prototype of functions or signature of functions? Because to instruct to the compiler regarding usage of these functions. Okay. Type of the function void. It doesn't return any value. What we give, just that will be displayed. This is the function name, user defined function name. We can give our own name. These are the arguments. Either we can write int comma int comma int, or we can use these arguments also, no problem. Okay. Here I am going to use one L array, number of elements, element. Okay. So like that we write here prototype or signature of functions about to the main. To instruct to the compiler we use these prototype of functions. Unless we use, we will get prototype error. Okay. For the sake of compiler we use these functions. Unless we will get prototype errors. For this linear search, now we are going to find a key element from the given list. I will explain with the example. Okay, you see here this is the list of array L. Okay, 1 2 3 4 5 are elements. Here this is the recursive method. In this we will, what's our element? For example, if I give the element 4, okay, my key element is 4. This key element is 4. I am going to find from this given list. Okay. In the recursive concept, we will come from the end of the loop, end of the list, end of the array. Okay. This is the list of array. Okay. I will check from here. Either my key element 4 is here or here or here or here or here. Okay. If it is not there, element is not found. Okay. So for this purpose, here we use recursive concept. Okay. And in non-recursive concept, you see here, in non-recursive concept we check from here. Either our key element is 4, either 4 is there here or here, L of 0 or L of 1 or L of 2. L of 2 is 3. L of 3 is 4. Yes, my key element is found. Okay, like that we search in non-recursive from left to right. Okay, so here I will explain with this program. L of max length. What's the max length? 10. Maximum elements are 10 only. A num for number of elements. ELE is for key element. CH is choice. You see here my choice. My choice is either 1 or 2. Choice 1, linear search using recursion method. If choice is 2, non-recursion method. Okay, enter your choice. If my choice is 1, recursion. Choice is 2, non-recursion. If I give choice 1, okay, then here you see here, enter your choice. If I give choice is 1 less than or equal to 2, yes, and 1 greater than 0, yes, true and true, true. How many elements do you want to enter? I will enter here. How many I have given? Total 5 elements. Here I will enter 5 elements, number of elements. Okay, here how many elements you enter? I will enter 5 elements. Okay, after that, okay, we read the list. For reading the list through keyboard, here I am using function, or directly we can read the values through the keyboard, but here I am using function concept. Okay, so here whenever we read, we will go to here. Okay, this is the call function. From call function to called function. Okay, read list. L array, what I passed here, arguments. Okay, L is the array of elements, num is the number of elements. L is the array, num is the number of elements. Here I will read. Okay, here I will read the elements. Okay, this is the called function. Okay, called function beginning. Okay, int j. For the loop you enter the elements. Okay, j loop, scanf percentage. Through keyboard I will read the element L of 0, L of 1, L of 2, L of 3, L of 4. Okay, L of 0, L of 1, L of 2, L of 3, L of 4. That means total 5 elements. Okay, less than 5. 0, I have started from 0. So up to 4, 0, 1, 2, 3, 4. L of 0, L of 1, L of 2, L of 3, L of 4. You see here these elements. L of 0, 1, L of 1, 2, L of 2, 3, L of 3, 4, L of 4, 5. Total 5 elements I read. After that, after reading, okay, we will go back to our main function. Actual execution will begin from main. From main I called, then I call the function, then I entered into called function, then I will go back to my main function. Okay, then here after that we print list. Okay, it's our read list. Next print list. Okay, cursor come back from called function of read list to main function. After the read list, print list is there. L array, num is number of elements. Then we will go to called function of print list. Okay, here I am going to print the elements what I have given. Okay, that elements, here I will print the elements. For this I used j loop. Okay, j is 0 to 0 less than 5. L of 0, L of 0, L of 1, L of 2, L of 3, L of 4. I will print all the elements. Okay, before we search the element. Okay, now it's over. Then we come back to our main function. Okay, come back to main function. After the print list, what's there? Enter search element. Okay, now I am going to give my element. Okay, from this list, here if I give 4, okay, from this list I want to search this 4. Okay, my key element is, enter the search element. My key element is 4. I would like to search the 4. Either that 4 is there in this list or not. Okay, next, after giving that key element, here we will give the key element. Okay, my key element is 4. have to search that 4 element is there or not from the given list. Choice, switch case. Okay, in this many cases will be there. According to our choice, concerned case will be executed. What I have given earlier, my choice is 1 for recursion method. Okay, switch case begin. Okay, this is the conditional statement. Okay, next else search recursive. Here I am going to call my recursive function method. Here this is the call function, L array, number of elements, key element. Whenever we call, okay, this is the user defined function. For the recursive function, call function. Okay, then we will go to called function of recursive. Okay, here recursive function is there. Okay, this is the called function of recursive. Okay, next called function begin. A program is divided into subprograms, that each subprogram is called a function. Each function will perform a specific task. Here it's also one of the functions for this program. Okay, this is the recursive function for the linear search. Okay, this is the user defined name. What we give, same name we have to give here. In call function what I give, else search recursive. Here in called function also I have to give same name. Okay, if L of num. Okay, L of num, what's the L of num? L of 0. You see here, first L of num, my number of elements are, you see here, L of num, my number of elements, my number of L of num, what I have given, 5. L of 5 is equal to key element. What's the L of 5? You see here, here we are in recursive function. Okay, so here we have to go to recursive. Here recursive function, you see here, this is the recursive function. My L of num, my number of elements 5. L of 5 is equal to key element. My key element is 4. L of 5 is equal to key element 4. L of 5 is equal to 4. L of 5, here L of 5 is not there, L of 4 is there. Okay, so we will come to, okay, we will come to if, else if num, what's my num? 5. Okay, what's my num? 5. 5 is equal to 0, false. False and something, false only. We will go to else. Okay, next we will go to else case. Here else search recursive, num minus 1. What's my num? 5. 5 minus 1, 4. Okay, this function is called by itself, same name. You see here, this is the call function. A recursive function. Recursive function means function is called by itself. Okay, this function is called by itself. So we will come back to here. This function is called by itself. What's the num minus 1? 5 minus 1, 4. Is L of 4 equal to element, key element? What's the L of 4? L of 4 is 5. Is 5 equal to 4? L of 5, 4 equal, 5 is equal to 4? No. So we will come to here. What's the num? 4. What's the num? Now we are here. Num is 4. Okay. Is a num 4 equal to 0? False. False and something? False. Come to here. Okay. Next, else search recursive. Num minus 1. 4 minus 1, 3. Okay. 3 means, once again, we will go back from here. 3. 4 minus 1. Now we are here. 4 minus 1, 3. Now it's pointing here. Okay. My num is 3. Here 3 is passed. Okay. From here we pass 3 here. Key element. This ELE is the key element. L of 3 is equal to element. What's the L of 3? 4. 4 is equal to key element 4. L of 3 is 4. My key element is also 4. L of 3 equal to key element? Yes. L of 3 is 4. Key element also 4. 4 is equal to 4. Okay. Here 4 is equal to 4. So element percentage D is present at position. What's my key element? Element 4 is present at position num plus 1. What's the num? 3. 3 plus 1. Fourth position. This element is at fourth position. 1, 2, 3, 4. Fourth position. Like that we will write. For example, if I give my key element is 9. Is there 9 in this list? No. So here we traverse from here 1 by 1, 1 by 1, 1 by 1, 1 by 1. We will come up to here. Okay. But we won't find 9. Okay. My key element is 9. Okay. So at the time we will come up to here. Okay. Then here L of 0 is equal to element. For example, if we traverse from here like this 1 by 1, 1 by 1 in recursive function. Okay, 1 by 1, 1 by 1, we will come up to here. After that 0 minus 1 minus 1, we will come to here. Okay, L of num. Last you see here at this position, we will come from here up to last. L of 0. Is L of 0 1? 1 equal to 4? No. Else if. What's the num? 0 is equal to 0. F is 0. What's my num? 0. Okay, while we are traversing, we will come to here now. Num is 0. 0 equal to 0? Yes, true. What's my F? F is 0. Flag value. Okay, num is 0. Num is 0. Yes. F is 0. Yes. True and true, true. Element is not found. What's my key element? Element 4 is element 9. My key element is 9. Na? Element 9 is not found. Like that we write in this recursion. Okay. Next we will, for example, if I give in this, I have shown two methods, recursion and non-recursion. If you want, you can split according to your requirement of either recursion or non-recursion. Okay, then we will come back, break. Break means come out from this switch case. Okay. Next, after the switch case, what's there? After the switch case, we will come out from this if, then we will come out from this. This is the main block. Okay. Next, for example, if I give choice, okay, if I give here choice 2, okay, 2 less than or equal to 2, yes, 2 greater than 0, yes, true and true, true. Okay, so my choice is 2. 2 is for non-recursion. Okay, how many elements do you want to enter? We same procedure. Okay, for example, if we want to find non-recursion, okay, next we read and we print the elements. After that we give search element. After that we read that search element. Okay, then we will come back to the switch. We enter into switch. My choice is 2 na, so switch off 2. Concerned case will be considered and executed. Next, what's there in the case 2? Non-recursion. L search non-recursive user defined function. L array number of elements, key element. ELE is the key element. Okay, this is the call function in the case 2. I have given choice 2, so concern case is executing here. Okay, case 2 is executed. Okay, here we call the function for the non-recursion method. Then we will go to called function. 3 parameters are there. L array, number of elements, and key element. Non-recursive function. You see here, this is a non-recursive function. Okay, this is a called function. We cannot give semicolon at the end. If we give, control will not enter into this function. Okay, we read and declaration and initialization of variables. For loop I have taken 0, less than or equal to num minus 1. Okay, this is the non-recursion concept. Non-recursion concept, you see here, non-recursion, this is the recursive, you see here, non-recursive function, L array, number of elements, key element. Okay, in this non-recursion we traverse from left to right, J loop. Okay, J less than or equal to num minus 1, 0 to my elements total 5, 5 minus 1, 4, L of 0, L of 1, L of 2, L of 3, L of 4, up to 4, 0 to 4, that means 5 elements. Okay, to traverse I have taken here for loop. Okay, L of 0, L of J, J means 0, L of 0, what's the L of 0? 1. What's the my key element? 4. For example, if I give 4 my key element, okay, here you see here here you see here L of 0 is equal to element, L of 0 is 1. Is 1 equal to 4? No. Okay, this loop will be iterated. Now J will be incremented as 1, 1 less than or equal to num minus 1. What's the num? 5 minus 1, 4. No? 1 less than or equal to 4, L of 1. Is L of 1 equal to element? L of 1 equal to 4. My key element is 4. Na? Is L of 1 2 equal to 4? No. After that, next to traverse, L of 2. 3 equal to 4, L of 2. 3 equal to 4? No. Next, L of 3. L of 3. 4 equal to 4? Yes. So, element, what's this? ELE. Here, element 4 is presented position. What's that? 3. Okay. Here J is 3. Na? So, J plus 1. Here index is 3. But position, 4th position. So, J plus 1. Index plus 1 is the position. Next, F is 1, break. Okay. After that, we will come to here. What's my F? Whenever I found the element, I will set F is 1. At the beginning, F is 0. Whenever we found the element, I will set F as 1. So now F is 1. Next, what's the F value? 1 now. 1 equal to 0? No. So we will come out. Okay. This is the non-recursive function concept. In this we traverse from left to right. Okay. For example, if I give 9, 9 is the key element. Okay. When we traverse from beginning to ending, that 9 will not be there. Okay. At that time, okay, we cannot find here the element. So at the beginning what I set, F is 0. So this will be iterated, but we cannot find the element. So we will come to here. After iterating, we come to here. At the beginning I gave F. So this F will not become 1. Why? Because it will not be it's not considered. Na? If it is equal only, then F will be 1. If we found element, then F will become 1. But if we won't find the element, F will not become 1. At the beginning F is 0. Na? So 0 only. Okay. So 0 equal to 0. Yes. Element is not present in list. What's that element? Key element. Element 9 is not present in list. Okay. This is the program of linear search. Here linear means sequence search. Either left to right or right to left. Right to left. Linear means sequence search. Okay. Now we will, you see here, this is for non-recursive function. Okay. This is for recursive function. Okay. Now I will compile and execute the program. You see here 0 error, 0 warnings, 1 for recursion, 2 for non-recursion. In linear search, enter your choice, 1. Okay. If I give elements 2, 3, 4, 6, 2, 3, 4. How many elements do you want to enter? Elements in list are 3, 4. Enter search element. You see here, enter your choice 1. How many elements do you want to enter? 2 elements. You see here. Here 1 for recursion, 2 for non-recursion. Enter your choice. My choice is 1 for recursion. How many elements do you want to enter? 2. Enter that elements, the 2 elements, 3, 4. Elements in list are what I have given, 3, 4. Okay. I have given search element 6. Okay. If 6 is there, element 6 is not found. Why? Because my elements are what I entered 3, 4 only. But if I give search element 6, that 6 is not found. Okay. I will show another list. Okay. You see here. Compile and run. Enter your choice 1. Okay. If I give 1, sorry, you see here, compile and run. Enter your choice 1 for recursion. Okay, how many elements? I will give 5 elements. Okay, 2, 4, 6, 7, 8. Okay, here 1 for recursion, 2 for non-recursion. Okay, next I have given my choice is 1. How many elements do you want to enter? I want to enter 5 elements. Here I have entered the elements. Okay, 2, 4, 6, 7, 8 I entered. Then it displayed elements in the list 2, 4, 6, 7, 8. Here I have to give the search element. Search element from this, if I give 7. Okay, then yes, this is the recursion method. Element 7 is present at position 4. Okay, you see here 7 is 4th position, it's there. Okay, so like that we find recursion. Okay, if I want to find non-recursion, I have to give choice 2. Compile and run the program. Okay, enter your choice. My choice is 2 for non-recursion. How many elements? I want to give 5 elements. Enter that elements 1, 2, 5, 3, 7. Okay, here 1, 2, 5, 3, 7 I have given. My search element is okay, in this 3. Okay, you see here, 1 for recursion, 2 for non-recursion. Choice is 2 for non-recursion. Here I have entered how many elements? 5 elements. I entered the elements in the list, it is displayed. I have given search element 3. This is the non-recursion method. Element 3 is present at position 4 in list. You see here 3 is 4th position. Okay, that 4th position is displayed here. Okay, we displayed 3 is at 4th position. This is the linear search for recursion and non-recursion methods. If you like it, please share and subscribe. Thank you.